Okay, it is recording now. Yeah, thank you. Coming back to this exercise 2. So this one, it was a tad bit harder because we wanted the layouts from the figure. So in the pie figure, the only layout option that we had was a title that's easily inputted when you're defining a subplot. But in this particular case, since we wanted the other two figures that the code is copied below, they had different layout options. They had the X and the Y axis defined in both cases. So the heat map and the scatter plot. Also, the heat map had a color bar. As you can see, this color bar is smaller and in the different position. I don't know if you remember, but normally it's on the right side and it fits the whole figure. If you go below, you'll see the reason why we've done this, but these options were controlled here in this color bar variable where we define the X. Remember, the X in most cases is the position relative to the X axis. So since this is minus -2, if you see this as a 0, the color bar is here, which is the case, right? In terms of Y, it's the same thing. So we've put it above. And in terms of length, we've reduced it to half. This is percentage. So what we've done, we've just put the color bar in the top left corner. And we've done that because if you go to the subplots here, let me just run it. The color bar, it's in the right position, right? So this is so this is an issue with subplots and heat maps and other figures that have color bars. When you introduce them in a subplot, the color bar will not adjust to its position. The color bar will stay in the same position it was normally. So, for example, if I didn't alter this color bar option here, as you can see it by default, it's on the right side and it occupies the whole figure in terms of height. If I didn't do it, when I've defined here the subplot visualization, the color bar would be here, as you can see. So it's not that bad, but for example, if the legends were here, it would be on top of the legends and it would get messy. So in order to avoid this issue, already when you define a visualization in this trace, you already put the color bar in the place that it will be. So keep that in mind when defining any visualization with a color bar, and then you want to introduce it in a subplot. So this is the only difference in terms of code we had. The rest of the code is copy pasted from the previous exercises. So both the heat map and the trace data is exactly the same from the previous class. Now here, the only differences are we have 2 more visualizations. So let's put them in another row. So 2 rows, 2 columns. We have more titles, right? In terms of spec, remember the structure we had. Since we want to put the first 2 visualizations, the heat map and the scatter, on the first row, we need to put its type to XY. So type XY in the first row. And the second row will have the pie visualizations again. So type domain. We introduce the titles, the subplot titles. Here it's described what the row height and width do. So they define the space that each visualization occupies. After that, we add the trace. So for the heat map, there's nothing new. We simply add its data. As for the scatter, here there's a difference because the scatter had 2 traces, as you can see. So we had the trace for the 2015 sales and the other for the 2014 sales. And normally we append them in a single list, and we just feed it to the graph doc to the figure object. when dealing with subplots, I couldn't just put the example exercise 2 data inside of it because it would print out an error. You need to introduce them one by one or through iterative processes, right? So what we need to do is take the trace 1 and trace 2 and introduce them singularly and not at the same time. So as for the other traces, it's exactly the same thing. We just need to take in consideration that it's in a different position right now. We have them in row 2. As for the axis, remember that for X and Y type visualization, we use the update X and Y axis option. We just need to take into consideration again its position. So this one naturally is for the heat map, and the second one is for the scatter plot. Also, there's normal layout options that you can manipulate. For example, the height of the visualization, its title, it's exactly the same thing. And now we had a new option, or we introduce a new option, which is legend. As you might imagine, it changes the orientation of the legends that normally are stacked vertically on the right side to horizontal, so they are below. As you can already notice, there are some limitations when dealing with subplots. If you might remember, these first two legends are regarding the scatter plot, and the next ones are for the pie plot, right? But if you had a lot of legends from different visualizations, they would stack with it. It would get very confusing very quickly. So take that into consideration. The good part about that is, for example, when dealing with the two pie plots, since they have the same trace in terms of name, the legend product one alters both of them, right? Which is kind of amazing. So did any of you have any issues with, for those of you who tried with these exercises, or any further questions? Okay, I will assume you all did it without any issue then. So again, this is what I was saying. So the legends stack up together, and that we've put the color bar on its particular place and defined it before the subplot itself. So going on to spatial data. So I don't know if you've noticed, okay, but Professor Pedro Cabral really loves spatial data. Actually, it's one of his areas of expertise. I believe that's how you say it. And today we're going to learn how to encode spatial data, which means give. Vou partilhar, sim. Okay, spatial data. So which means given any data set we have that can be encoded into a map, for example, in our emissions data set that we've been using, we have the country values. We will learn how to, encode it in the map, right? So first of all, let's get the country points CSV. So let's just run this. As you can see, it's a simple data set that has the country's longitude and latitude. And the first figure that we'll learn will be the scatter geo. The scatter geo that takes both latitude and longitude. But before going into this particular visualization type, let's just take a quick look into the types of visualization plot they offer. So there are two main types. Let me just type them. We have the geo type and we have the map box. We'll try to go through all of them this class, but the geo will have, let's just put it like this, scatter and has Choropleth. For those of you that don't Choropleth. So for those of you that don't know, a Choropleth is a density map. So for example, if you just type Choropleth in Google, are maps that show values in terms of density in certain areas, right? So this is a very common example in terms of map information encode. And we have in Mapbox, we also have scatter and Choropleth, and we also have density. The main difference between the Geo visualizations and the Mapbox visualizations in Plotly is that Geo uses a map that comes from Plotly itself, so it only works if you have an internet connection. What you do is you encode the data in terms of either longitude, latitude, or name. We'll see later for the Choropleth. And Plotly automatically merges it with a map that it has online. So you will see below, you don't need to have a lot of information. It does that automatically. The only issue is that you can only merge on either countries or US states. So if you have information from parts of a country that is not the United States, you will not be able to do it with the Geo type of visualizations. So that's one of the biggest limitations, but it's much easier to use than the Mapbox. In terms of Mapbox visualizations, you can basically merge it with anything. So you have a particular data set which has information of any partition of a spatial object. For example, it can either be parts of a mountain, countries. If you had countries, you would do zero, but regions of a country. You can have anything as long as you have a GeoJSON. We'll see later what a GeoJSON is, but for short, it's basically a file. Google Map. I don't quite understand what you mean by Google Maps plugin, but as I was saying, for the Mapbox, you can basically plot any kind of spatial visualization. The only thing you need to have is a GeoJSON. Basically, a GeoJSON is the map itself where you're going to glue your information to. If you have a map of that can come from Google Maps, actually, you can introduce it to Plotly and then just merge it with your information. So we'll see that later, but basically a GeoJSON is simply a dictionary of a particular structure. So moving on, we'll see for both the scatter and the Choropleth, in both of cases, they have pretty similar structures. They only vary in this term that the only thing that you need to have into consideration is that the Geo type visualization uses a predefined map from Plotly. The Mapbox, you need to provide it a map in the form of a GeoJSON. As for the density visualization, we'll see later, but it's a simple variation or a use of both scatter and Choropleth. So, but first, let's go through the Choropleth and scatter type visualization. So as you can see, there's we already have a figure. Sorry, a figure built. We define this trace as a scatter geo. As you might imagine, it's the first one. We need to introduce the latitude and the longitude. This defines a point in the map. Also, take into consideration that your data needs to be in the standard EPSG 4.326 projections. So there are a lot of projections in terms of data, and if you have the wrong projection, the points won't be in the place that you want them to be. So take that into consideration. This is the standard one, so in most cases your points will be in this information. But basically, our data set has a point in terms of X and Y, latitude and longitude for each country. And this is exactly what you're doing. So this is a clear match with the normal scatter visualizations that we have. We simply, instead of an X and a Y, have longitude and latitude. As for the modes, we are choosing the marker mode. So we want a point. We don't want to merge the points together in lines. So this is, I don't know if you remember, but this is equivalent to just typing markers, because this is the first value of this list. So it's exactly the same thing. As for the text, as you might remember, this option gives to each point a name. So since we have the name of the points, might as well name them when you hover over them. And for the marker, we are simply saying that the point for each of the countries will be of color red and of size 3. Now, in terms of layout, are the biggest differences when going to spatial data, at least in practical programming terms. So for the geo type visualizations, you have a geo variable where you have a lot of possible things to change. As you can see, most of them are pretty straightforward. And you also have the normal options that you have in any other layout. Let's just run it. So I've commented the figure shows because this will get really heavy. So try to rerun it after you see it with a comment so it deletes the image itself. Either if you don't do that, it will probably get really slow. So as you can see, you have a map of the world where in each particular country, I just zoomed in, you have a point of that particular country, right? So this normally shouldn't be the way to show it because the normal projection that we're used to is not the orthographic, which is the round globe, but it's the rectangular, I believe. So if you type rectangular, don't worry if you don't remember. So it's not rectangular, equirectangle. So when in doubt, make a mistake, right? This is the list of all of the projections available. So the standard one is the equirectangle, rectangular. Oh, this is the standard one, right? This is one of the cool parts that the Geo visualizations have, is that you can alter every projection. And there's a lot of options, right? So let's just make a mistake. So whenever you want to showcase data, there's a lot of ways to do it, even these weirder ones. So, but feel free to try. Also, there's a lot of options in terms of coloring your map. So if you're trying to embed it in a site or a dashboard, whatever, you probably have a theme. So the map should also follow that theme. So you have land color, lake color, show. There's a lot of options that I actually would like to show you in the references. So again, if you don't know something, there's also the possibility to go to figure reference and you can quickly find it. So in this case, we want layout and geo. So in the search option, type, you need to be inside of it, layout geo. So here it is, all of the properties that the layout geo variable has. So you have domain. The domain normally refers to the position of the visualization. So fill bonds, resolution, scope. The scope is the initial zoom that the map has. So if you type world, we'll see the world for first visualization, but if you were to type USA, you can do it. The visualization would start zoomed in at the USA. So let's just show it. So as you can see, why can't you see?
Sorry, Professor, can you repeat this procedure again? Because in my case, when I type USA, my map has an error and does not.
When you type scope USA, it prints out an error.
Yeah.
So
Can you move up just to see
Oh, sorry.
if I do anything wrong?
And just put in the normal.
Yeah.
So, but let me just, why did it stop rendering? So let me just try to, no. So, well, if I make a mistake, he corrects me, right? World, okay. Oh, okay, so.
Yeah, with the world, mine works, but when I change it for USA, it does not work.
Oh, that's really weird, actually. So
my figure is blank, so I'm not sure if there is any.
Yeah, mine as well. So let's try another one. So yeah, well, I don't know why it is printing out a mistake, but yeah, this is what it was supposed to happen. So
yeah, works. Okay, okay, thank you.
Yeah. So, but moving on, there's also a lot of options in terms of personalizing your, well, the look of the map. So that was what we were seeing, also projection, rotation, etc. The center is it's also an option that we're going to use, which is the initial visualization. For example, if you didn't want to center it around Europe, Asia, etc. If you wanted to center in a very particular, yeah, it goes blank with USA. Maybe it's a bug right now. But the center option is very useful, and we are going to use it in the exercises because it centers it zooms the initial visualization. So for example, if you wanted to only see the parts of Lisbon, well, naturally, if we started with the world, we would have to navigate to find where Lisbon is in this, so a very small, tiny black point that we need to zoom in. So the center option allows us to center the initial visualization of the map, and the zoom, which will be below, well, it's the initial zoom. So even if we were centered in terms of longitude and latitude to Lisbon, you would probably only see a small dot, and we would use the zoom option to actually start seeing Lisbon in the first time we render the map. So visible is the normal thing, so it's either visible or not. Show coastlines. So here there's a lot of options that you can play with. So show land, land color, etc. Remember, every color option in Plotly can either be in Xcode, can be typed. So if you type blue, it probably will catch the blue color, and it can be also RGB. So it's a list of 3 values, one for red, blue, and green. So if you want to find some particular X color, you can just go to Google and just X color code, and any one of those has the code of color. So you can easily find the code of a particular color very quickly. So, but moving on, this is the scatter geo. It's not that difficult because you only need to have the longitude and latitude, but in terms of practical difficulty, it's basically the same as the normal scatter because you have an X and a Y, which is lat and longitude. The only difference is that you have more layout options, so land color, etc. So, oh, now we have the first exercise, right? So what I was expecting, or I am expecting, is that while you're doing the exercise, that if you have any doubt, you can speak so everyone can, well, get that answer right. So let's try to do it. Yes? So now it's 7:10. Let's give it like 10-15 minutes for you to try doing it. So basically it's doing the same thing, but for this DF Lisbon dataset, the F Lisboa dataset. So I've already typed some code. So it should, okay. So this is in Markdown, but if you want to use this, this is just to help you out. Just copy and paste it in a normal cell. So this is already for you. Why it's kind of deformatted. But just try to do it now, okay? And if you have any question, you can ask me now.
Sorry, I'm a little bit lost because the first step was to enter the link, and my link doesn't work. And the second part that you want us to do is to copy the code from the world map and try to do it for Lisbon. Or I'm getting.
Sorry, going to the link. How so?
No, I'm just stuck in the first part because this link that you have here, raw, that starts with raw.github.
Oh, okay, okay, okay. Oh, the this one, for example.
Yeah, yeah. It's not too. It's not supposed to go there, so I got it wrong.
Oh, but so, but if you want, you're trying to download it to your computer, right?
Yeah, but this link goes to.
So, oh, but the
yeah,
thing
but
is,
yeah, we can leave it. Yeah.
no, but so the full link has this on the end. So if you wanted to go to that particular link, you would need to use this one. So this.
Okay. Okay.
Yeah. So yeah. So as you have above, you have a data set. Here you have numerical values that we are not going to use, at least for now. But you have as well latitude, longitude, and names. The only difference is that instead of having countries, you have conselhos from, okay, regions from Lisbon, right? Partitions. So what you have to input here is latitude, the column latitude, column longitude, column text, and that's basically it.
And do you copy the code from the last exercise of the work?
You can copy the code from the last exercise. The only thing you just need to make small alterations. So, but for example, try to use a different color, so blue here or something. So is everyone being able, is everyone okay with this? So any issues?
Well, at this point is giving me a syntax error.
So sorry, a syntax error?
Yes.
I think it's because of the name. I am having the same problem.
So are you putting commas at the end of the? So you're probably saying, okay, we have.
Okay. Maybe let me see. I didn't put the comma after each. Let me see.
Yeah. So to separate. So actually, you only need to input each one of the columns in the commas, yeah.
Well, for this exercise, it's just missing the latitude, the longitude, and the text, right?
Yeah. Yeah, this one is pretty straightforward.
And the DF has to be changed to DF wishbone. And I think if you copy the code.
So yeah, if you want to copy paste it, yeah. So, but while we're waiting, let's just give it a little while longer. Try to
for developers of the open source bokeh project.
Try to change the land color or the lake color, or try to go to the figure reference. So we have it here.
It is easy to create simple plots, but it's also capable of versatile and highly expressive graphics.
So can someone please mute your microphone though?
It can present streaming and dynamic data sources and can handle large data sets in a number of...
No.
Bokeh was designed from the start to take advantage of modern browsers for presentation and can create standalone but highly interactive...
Okay, I believe I can mute you all, and whoever wants to speak can unmute itself so we don't have that
from the comfort of Python without needing
that video playing, right?
Or lots of web tech. Here we see a variety of plots and applications that are possible with Bokeh. There are simple, single plots, but also sophisticated applications with controls for interacting with and drilling down into the data. We can have links.
Let me just see how I do it.
And streaming financial data. During this course, we will learn how to perform basic plotting using the Bokeh.
Oh, okay. But as I was saying, while we're waiting a bit so everyone can try it, let's just go to Python Plotly. So to the figure reference. Again to the layout geo option. So again, layout geo. And try to find some options to change. So let's see the most obvious one. So coastline color or coastline width, show land, that's pretty binary. Land color. Try to change it.
Is there any option to show the borders
of the countries?
Yeah.
So, land, yes, there is. So where was it? So
show countries.
Countries with number sets line width. There it is. So countries width, it sets line width of the country's boundaries. Okay. And there it is, sets line color of the country boundaries. It's these options here. So let's try country color. I'll use it on the previous exercise.
So just one question. By the end, you should get like a pop-up from a browser and seeing the world map, right? With some dots on Portugal.
Yeah, exactly.
Ah, okay, nice.
Yeah, that's a good thing you've asked. So remember when I talked about the center option in the figure reference? So you have a problem that you open the map and you only see a small portion of the map because it's zoomed out, right?
Yeah, so, but now I can add like into the scope just for Portugal or Europe in that case, right?
Yeah, but you can only do for Europe because it only has a limited amount of continent, or it's only for the continents. But if you go to this option center,
okay.
Actually, there it's already typed below, so let's do it. Okay, I'm on the exercise. So if you come here and inside of it needs to be inside of Geo, right? So here.
Just a sec, you're saying it's inside
of the Geo variable. So
okay, layout.
So center has two variables. It can have two parameters. It has latitude and longitude. So I put So we need to center it around some coordinates, right? So what we can do is center it around the first coordinates that we find, since they are basically very near each other. So to choose the first coordinate is, in terms of latitude, is df Lisbon, Lisboa, lat, then .iloc. The .iloc method finds a particular index. So let's choose the first index, index 0. This will give us the value. Oh, sorry, it's on the other one. No, it's the same thing. This will give us the value of the first latitude. And let's do the same for this first longitude. So the exercise goes naturally at lat, df this one, right? Df Lisboa. And now I have a typo. And here we have names or name. Let me just take off this one. So name lat one. Okay, so if you come here, the map will be centered now. The F1 invalid syntax. Oh, I forgot as well the color. Nice. So if you render the map, so since we are on Google Colab, you can't use the render equal to browser. So if you were on your computer, it will pop up another window. So as you can see, I've changed the ocean color or the lake color. It is centered around Lisbon, but we still have the same issue, right? Because the map isn't zoomed in. And actually this projection is not that good. So what we can do is use the zoom options. So you come here inside of the Geo variable and set the zoom to, it needs to be a number higher than 0. So zoom equals to, let's say 7.8. Zoom, why is it not? Did I put it inside of zoom? Let me just see. Scatter map box. I don't know why this on Google collapsed. So exercise to build. So center, zoom. So what I'm seeing is that on the exercise below, I already had this layout option set, but zoom is actually inside of this. I don't know why it's not setting. Well, for now, let's just skip this one because let's not lose too much time.
Can you just show me the code for the center you just typed?
Oh, this one here.
Yeah.
Okay,
because
yeah.
I'm getting an invalid syntax, and I'm pretty sure it's the same.
So I don't know. Can you spot the difference? So if invalid syntax is probably there's a comma missing or or a parenthesis somewhere that's not fitting well. So center equals to a dictionary, open lat dot comma longitude something and close.
Well, the only difference I see is the double quotes instead of a single quote, but
no, that shouldn't be an issue.
Yeah, exactly. Okay, yeah, but
well,
I'll figure it out.
Yeah, that's so. But for the zoom, I was trying to find. Let's just so layout geo zoom. So apparently it's projection scale. Oh. So here it is, the number greater or equal to 0, defaults one zoom. So as you can see, it's inside projection and it is the value scale. So if you come here, we actually didn't have any projection for this one. So let's give it a projection. Oh, actually it is here. So inside of Geo as well, we have a type orthographic. Let's use the normal type, so equirectangular. Rectangular. Let's set the scope, the scale to a value higher than 1. So scale equal to 7.8. Let's see how it changes. So as you can see, it's much more zoomed in, right? So maybe more than 7.8. This part is kind of a trial and error in terms of scale. Apparently it doesn't zoom much more. Okay. But still, it's an improvement, right? So, but did any of you still have any issues with this exercise?
No, not really.
Okay, nice. So going on to the Choropleth Geo. So in terms of the Geo visualization, this one is kind of different since we are not using longitudes and latitudes anymore. Let's open this up. So as for the Choropleth Geo, we need to get we'll use the emissions dataset again. So these are the, oh really? So let's just, before we get there, so let's use your colleague's recommendation. So I'll take the scale off and just use the scope as Europe, and we have the center. Error. Session I was not unique. So it centers around Portugal, right? Yeah, you're right. So, and can we zoom further, for example? No. Yeah, but it's an improvement for oh, this was an error. Yeah, it zooms more. Yeah. Oh, thank you. So if the initial scope instead of the world is Europe, which means it starts zoom more, it starts further zoomed. You can further zoom it compared to the scope equal to world. So that's an improvement. Yeah. But moving on, for the Choropleth Geo map, we don't use latitudes and longitudes. We use keys to merge our data with the map itself. So the only options we have in terms of Choropleth Geo is either country names, country codes, or US states. So this is the biggest limitations of the Choropleth Geo. It's very easy to use in terms of final product, what it gives out, but you only can merge it with either country names or United States states. So for this, since our emissions dataset has countries, data by country, let's use it. So we download it. This is just for us to see the columns. Remember, the dataset had values for each year, but in this particular case, we only want one value per country. So let's focus on a particular year. This is already done, so it's just some data prep. But here we have the CO2 emissions for each country in the year 2000. If you want to choose any other year inside of the scope, so from 1990 to 2014, you're welcome to do it. But either way, let's move on. So the good and bad part about the Choropleth is that you don't need to have a lot of information to actually put it to work. So you only need a column with a country name, but you can only use countries and US states. So if you have data for this, it's amazing, but if you don't, well, you can't use the Choropleth Geo. In terms of structure, it's very similar to the heat map. So remember, the heat map had an X, a Y, and a Z. So here we only need to merge it with one column, which is the locations variable. So we are pointing to the country name column. Here, the location mode is where you define how you're going to merge. If it's going to be with the country name or the country code. The country code are the three initials that define a country. So it's called country ISO 3 code. There is a country ISO 2 as well, which are two letters that define a country. For example, Portugal is PT. And it can be with US states. So these are the only three options for the location mode. If I make a mistake, it actually prints out the possible options. So ISO 3, USA states, and country names. So as for the Z value, it's going to be the value that's going to be printed out in terms of color variation in the map. So we are going to use the CO2 emissions. In this particular case, since there's a big disparity between emissions, and since China has a lot of emissions, for example, all of the map will be of one color in China, very red. So we've applied the log scale so that the values are closer together, and you can see some color variation. The text variable, it's the same for everything. So it's the value or the string that appears when you hover over with your mouse. And the color scale is the same as for the heat map. So we've chosen Inferno. Here, in terms of layout options, it's exactly the same thing as for the scatter geo. So we have land color, lake color, ocean, show ocean or ocean color. So nothing new there, taking into consideration that since this is a choropleth and it will be over the countries, the colors, probably the land color won't make much difference because it will be covered up by our data. But if we didn't have every country, so the country that we wouldn't have would appear as the black in this particular case. As for projection, we have put orthographic, which is the globe, but let's put equirectangular. Okay, there's an error there. So, but you can use any one of those. And there isn't a show here, so I've had commented the show. So as you can see, each country has a value, and the value is described by its color, and when you hover over it, it appears its number. So this is log scaled, so the numbers are very low, but still you get the point. So we use the log scale because if we didn't use it, as you can see, since the variation is very big, you only see a mild difference in China and the United States. So since every country has a relatively low emissions level and the other two have a very high, since the difference is very big, well, you understand, right? So it is beneficial for this particular visualization to have a log scale. So let's put the log scale again. Yeah, and here it is. Naturally, I wanted to give you an exercise where you could do the same thing, but as in the previous one, but as a choropleth. So you have the same type of data. This is one of the limitations of the Geo choropleth. So there's no way to do it because you can only merge on either countries or US states. So yes, there is a possibility to invert the colors of the. Yes, there is. I don't know it by heart, but let's go here. So heat map, no. Okay, so I believe it's reverse scale. Reverse scale. Oh, here it is, heat map traces. So since this is basically a heat map, oh, here it is, Choropleth traces reverse scale. So if you go here, reverse scale, reverses the color mapping if true. So yeah, let's see if it is this one. So you come here, so it's inside of the trace. Set it to true. Okay. So yeah, here it is. There are negative values because the logarithm of a value between 0 and 1, it's negative. Yeah, moving on. So this is basically the geotype visualizations. They are pretty straightforward. So with very little spatial data, you can already visualize a lot. So you only need latitude, longitude, or country names and US states. The only issue is that you can only do it with these particular keys. So if you wanted to use our example of the Lisbon partitions to plot a choropleth, you couldn't with the Choropleth Geo. You would need to use the map box. But first, let's learn how to introduce a GeoJSON inside of a visualization of type map box. So before using a GeoJSON, let's see what it is. So in terms of structure, okay, there's a mistake here. It's GeoJSON. It is a dictionary. It has two keys, so it always says type feature collection, and inside of the key features has an array of features. Each feature, for example, in the country example, it's a country by itself. So here it is, it's an array with features, and here it will be feature in the properties would have Portugal, for example, the feature 2 will be Spain, feature 3, etc. So a GeoJSON type feature collection features an array of features. Each feature is a dictionary of type feature. It has properties. Here is where you drag any kind of information. So in the country name or that partition's name, wherever, it can have a lot of information. The ID is something not so common in GeoJSONs, but it is required for Plotly. So this key here is how you're going to merge your information to the GeoJSON or map itself. So, for example, if you wanted to use the same example as before in the Choropleth with the country names, here would be the place where you put the country name so it could merge to it. The geometry key is also a dictionary of type either point, line, string, etc., and it has coordinates. So, and it's the coordinates of that point or polygon. This is not a very good example, for example, because a point only has 2 coordinates, right? So this would be a line, for example. But coordinates can be a very big array, so it can have a lot of them, as we'll see in the examples below. So you can see a particular GeoJSON. If you have downloaded it to your computer, this is how you import it. The JSON. If you're on the internet, if you're going to use the GeoJSON from the internet, as I'm going to use it, this is the way to do it. So this is a your lib request. So you just use it to open the file that's online, and use the JSON library to open the JSON file. And this data geo will be the final variable that will have a dictionary of that particular type. So any question? Okay, so remember, a GeoJSON is a dictionary that has type and features as its 2 primary keys. So dictionary lets access the features, and since it's a list, we'll access the first feature. And in this particular GeoJSON, it is a list of every country and its coordinates, its borders. So the first one is actually Aruba. As you can see, it has type equal to feature. This is always the same. Properties, here we have the country name and the country ISO 3 code. And in geometry, it's a polygon, and there's a lot of, well, actually there's not a lot of coordinates, but there are some. So what we're missing to merge with Plotly is the ID, right? So if I wanted to use it in a figure, in a Mapbox figure, it wouldn't be able to merge your information with the figure itself, because he wouldn't know where it is. So you need to add to each feature an ID. For example, we'll use Aruba as the ID. So this actually requires a bit of knowledge, well, some knowledge in terms of programming. This is what we're doing here, but it's already done. But this can be sometimes challenging, because it might be hard to find information to merge to yours. So here what we're doing is, for every feature, since there isn't an ID, it will add an ID to each feature. And the ID will be this admin variable, which is the name of the country. We could use the ISO A3 code as well. But when you come here, there wasn't an ID. Now it is. So there isn't yet because I haven't run it, but now there is. And if I run this again, you'll see that it will have an ID right here. So keep that in mind. It needs to be, in order for it to be used in Plotly, in a Mapbox object visualization, it needs to have that structure. So that's really important. So what we're going to do now is exactly the same thing, but in the Mapbox visualization. So here again, we have the dataset with the latitudes and the longitudes and the names. And now we are going to define a trace of type scatter mapbox. So again, same thing, latitude, longitude, mode. Again, this is the same thing as doing markers, text. Again, the name of the country. Again, red color tree. The difference here is that instead of using the Geo layout options, you are going to use the Mapbox layout options. So this style option defines the visualization as a blank page. And here in layers is where we're going to introduce our GeoJSON map. So this requires a bit of tweaking around. So what this is basically a list of dictionaries. So let's print this out so everyone can see. So let's just, okay. I don't know if most of you know how to do a cycle inside of a list. So what this is doing, this is basically defining a dictionary with these values. So dictionary with a key below equal to traces, type equal to fill, fill equal to dict, outline color, and where each of the features is one of those features inside the GeoJSON. So let's just run this. There are a lot of features, but so better not run this because it will be very crowded. But what we're doing here is creating a dictionary. Let's just use the first two features. So as you can see here, this is the list of the features of a GeoJSON. We are only we cut the array on the first two values. So we are only using the first one and the second. So the Aruba and the country that comes after it. And what we have here, so the second country has a lot of points. Wait, okay. Actually a lot, okay, there it is. So we have a dictionary with type below equal to traces, fill equal to outline color gray, and source equal to that particular feature. So we have the geometry, we have the ID, Aruba, we have the properties, and that's it, right? And here Oh, and we also have the type equal to field. And here we have the second value. So this Aruba is when data geo equal to 1, or the first feature, and the second country is probably Afghanistan. I don't quite remember. Is when we iterate through the second value of this feature list, and well, as you can see, it's the same thing, but for a different feature. I know this is kind of confusing, so to say, but this is the usual structure. And what we're doing here is putting each country as a layer. So we are building the map country by country. The source is the feature itself. Below is simply so that it doesn't overlap the points that we're going to put on top of it. So it's below the traces. Type fill is because we are giving it points that define the country. So we want it to fill the points so we have a geometry instead of separated points. And here in the fill option, we are just saying that the outline color is gray. So if you run it, let me just delete what I've given you. So again, someone doesn't know how to put mute. Let me just. Okay, it stopped. So, but if you run this scatter map, so one of the issues here is that since the GeoJSON is very heavy, there's a lot of points. This gets kind of slow here. Yeah. That's because the file itself, the GeoJSON, it's very detallado. So it has a lot of points. I'm not. Yeah, as you can see, it's slow. So it's very heavy. What I meant to say. There are files that do the same thing, but with detail. That's the word, but with less detail. So if I zoom in, so a particular place, as you can see, there's a lot of unnecessary for this particular visualization point. So we did not, so there's a point here, a point here, a point here, here, etc. We didn't need so much detail in this particular visualization, right? So that's an issue when choosing GeoJSONs. This one is very big, actually. So as you can see, this is exactly the same thing. Well, we are missing some countries here, but it's exactly the same thing, but much slower, right? We aren't missing some countries, they still haven't rendered. So if you want to render countries, you're actually at a disadvantage compared to the Geo visualization. But if you want to render anything else, you'll probably need this one. So the next exercise, since this is very slow, don't forget to rerun it commented so it erases the visualization. So for exercise 2, let's give it like until late. I want you to do the same thing, but for our data set. So you have a GeoJSON with, so let me just zoom in, go up. So you have a GeoJSON with 16 partitions of Lisbon. You have actually Lisbon, Cascais, etc. And I want you to introduce it inside of GeoScatter visualization. So you actually need the JSON file, and you need the Lisbon DF file that we were using. So here I've already started doing it. So, okay. So I don't know why in Google Colab this gets so weird, but just copy, open a new cell and paste it. So there's a lot of, already a lot of stuff here pre-made. So let me just put it like this. So what you need to do here is complete the lat, lon, and text. This is from the Lisbon DF file. And actually here in the map box, since this is kind of challenging for the first time to understand, it's already built. So again, what you need to do is simply put, basically this is a copy paste exercise from the previous one. This is simply to show you what the possibilities that you have here. So you have lat, again, and for the text, you have the Lisbon name. So don't forget the comments. Invalid. Okay. So, oh, there's also a column missing here. Def. Did I call it Lisbon def? Is it possible to smooth the boundaries? Okay. So, what do you mean by smooth the boundaries? Like a less detailed map? Okay. So the boundaries, for example, what we have here, the boundaries are defined by each point. So if you have more points, it will be more detailed. And if this is slightly inwards or outwards, the answer is no. So you need to find a GeoJSON that it's simpler. What you actually could do, for example, is if this is a list of points that define a boundary, is for example, for every 2 points, delete one of the coordinates. So, for example, this is a point, this defines a line. So this latitude and longitude and this latitude and longitude define a line. And in the middle, something goes inwards. So imagine there's a crevice on the land. If you deleted the point in the middle, it would be a straight line, the boundary, and it would have less detail, but it would be less heavy. So yes, you can do it, but it might be kind of hard, because if you delete some points that are important, you might lose the whole figure by itself. So, but yeah, one way to do it is delete every other point. So yeah, let me just delete this one, this kind of bit. So now we can comment it. So could you all do the exercise? Oh, well, it's already done, but
can you just show the code, please?
Oh yeah. So it's Lisbon DF actually. So Lisboa, no. Lisboa DF or DF Lisboa?
DF Lisboa.
Okay. Okay. This is actually you only needed to copy and paste what you've done before, because I already done the layout part. So, but if you run it, oh, it's render equal to browser. So this is for those who are using your home computer, own computer. So here it is. So we have the coordinates that are centered on top of the layers that we've given it. And we have the particular, so we couldn't do this, define figures on the Geo Visualization type. So yeah, this is pretty much more useful. Also, here we also have the center, and if you might notice, the zoom is here instead of inside of projection. So there isn't any projection option in the map box naturally because you are giving it a layer, so you cannot bend the layer. So the zoom option is here. So yeah. Also, another thing to keep in mind is that here for markers you could use, for example, line as in any other scatter visualization. Lines. It has an S. So. And it would make a line between the points. The line is defined by order, so they are weirdly ordered in terms of what appears. But for practical uses, for example, if you were plotting plane travels or something like that, or plane travels, something like that, it might have some use. Also, you also have the text option, so it would, instead of a point, appear the text that represents the text name, the value. Probably the text value is in the same color of the background, so it doesn't appear, but nonetheless, it is here because when you hover over it, it appears. So, but moving on. Did you all manage to do it? This one was. Okay.
Yeah, for me it still appears the syntax error. Don't get it.
So actually, this one came with a mistake from me because it didn't have a comma here. So, does it tell you which line does the syntax error is? So, oh, sorry. So,
line 7.
Line 7. So it's in the beginning. So. Well, that's odd. Oh, what we can do is, for example, if I give it to you like. Oh.
Okay, it's done. Yeah, I missed the comma after mode and markers.
Okay. Okay. So nice. So moving on. So as for the Choropleth Map Box, if you remember, you had locations and location modes in the Choropleth Geo. Here you need to feed it the GeoJSON itself, which means the full dictionary. You need to feed the values that will merge with the ID of each feature. So remember that we defined the ID of each feature as a country name, or as the country's name. So here we are using the country name column naturally. And as for the Z, is the Z value of the choropleth. So the value that defines the color. Here is the same thing as any other heat map. As for the layout of the map box, we are using exactly the same layout, except we are not using any center or zoom because this example uses again the CO2 emissions dataset. So if you run it, let me just uncomment it and take this render equal to browser. This one is kind of heavy, so some of you might have some problems running it, even for Google Colab. Okay, so this one is so heavy that it can't run, at least in Google Colab. I don't know for you. Could you run this one? I know it runs in my computer, but in Google Colab it's not running. So I will assume that everyone could run it. No, okay. Oh, but could anyone run it in Google Colab? So this is kind of heavy, this one in particular. But as you would see, it would be exactly the same as the other Choropleth, but here we are using our own map. Mine takes, okay. Well, mine actually goes down here. It actually says reconnect. Oh, well, good. So, but for our next exercise, oh, you're in, okay. Apparently in Google Colab, it's too heavy to run. But for our next exercise, exercise 3, we're going to do exactly the same thing, but for the Lisbon example. Here, there isn't any pre-made code, so to speak. You can copy the one above and transform it to fit the data set. So this one is the more difficult exercise. So the hint here is that the key inside of the GeoJSON is the ID is the name of the partition. So I'm not managing to say conseil in English. So the name of the partition. So what you have to put here in the locations is the name of the Lisbon DF, Lisboa DF. So DF Lisboa. So as you can imagine, the column name will merge with the ID here. Exactly, thank you. Municipalities. Municipal. Yeah. As for the Z value, you can either use sales from 2014 or 2015, doesn't make much of a difference. But try to do it here. So remember that you'll also need to change this part because the example from the Choropleth uses the other GeoJSON. This one is much smaller or lighter, so it will run smoothly without any issue. So but try it. I'll give, yeah, let's give you like 10 minutes if you have any questions. So feel free to ask, please. But let's do this until 8:10. Any doubt or something? So I was expecting more doubts or something like that, no? Are you at least managing to do it all right?
Still trying, sorry.
Okay, yeah. Okay. This GeoJSON use for the visualization is kind of the hardest part in terms of Plotly. But when you are able to do it with some ease, it gets really, really useful because you can basically visualize anything that you want as long as you have a GeoJSON. So yeah. Can you show us the example? Do you want me to do it now? Well, I'll give you the example, yeah, but let's just give you some minutes more, so. If not, it's okay. Don't worry. PF code. So what your? No, it's not supposed to take long to run, actually, because there's not a lot of data here. So, okay, let's do it slowly, right? So,
Just a quick question.
yeah, sure.
So, in the location would be DF Lisboa, and inside we'll be choosing like the category of the table, right?
Yeah, in this particular case, it would be the column names, yes.
The column names, okay. But
yeah, because
okay, tell me.
No, I was going to say, because as you can see, when we've opened up the GeoJSON, the ID key was the name of the, well, luckily, right, was the name of the municipality. So for example, if this was a code and we had another column that said municipality code, we would have to use that. So we need to merge the ID of the GeoJSON with the localities column. So we are just pointing out where you will merge the data. Did I answer your question?
Yes. The thing is just I don't know how to put that in code, right?
Okay, so here for the let's do it. Okay, so I'll just repurpose the code since the layout will be fairly similar. Just copying the code from the previous example. So it's still a Choropleth Map Box. Our GeoJSON was called, what was it called? It was called Lisboa Geo. So here Lisboa Geo. Our locations will be the name column in def Lisboa. Why? Because the IDs are the names of the municipalities which merge with the names with this column. So what we have to put here is Lisboa def name, right? So def Lisboa. As for the value, let's just choose the 2014 column. So 2014 sales, or yeah, sales 2014. So in terms of the trace itself, we don't have to change anything else, right? What we could also put here, actually I don't know why it isn't in the example, is text, and again use the location option. But this is not really necessary, it's text. So in terms of color scale, we want the same color scale. As for the name of the color bar, well, it's not CO2 emissions now. We are using the, but it, for some reason. Yeah, the zoom will, we have been seeing the zoom, but it's pure luck. but it pure luck. What do you mean by pure luck? So, but carrying on. No, actually, it was me who made the JSON file itself, but sometimes you need to find ways to merge the data, so it might not be as easy. So it was lucky because I made it, but sometimes you really need to manipulate your data set either to get a column that matches or manipulate the GeoJSON to put an ID that will match. So sometimes that requires kind of some work for it to merge together well. Oh, but we'll go to that zoom issue as well. But color bar, it will be money, so monetary unit, because it represents the amount. As for the map box, we want a blank page, blank background. As for the layers, we are luckily enough, since every GeoJSON has the same structure. Here you can just change the data geo. That was the GeoJSON for the countries for Lisbon geo. So we still want it to be below the traces itself, which are the colors from the Choropleth type fill, which means when it defines the borders, you will fill the object that represent the municipality, and for the outline color, gray. For the title, let's call it exercise 3. Now we have the issue of the zoom, right? So normally, especially in the Mapbox, we don't have that scope to Europe. What we have is that center option. So inside of Mapbox, which is here. So it's an option of, it's a variable inside of Mapbox. We have center, which is a dictionary that has the latitude and longitude parameters. So if you want, you can just copy it from the previous exercise. So what we have center, so which will be where the map, when you render the map, where the visualization starts. For the center, we'll want the first coordinates, could be the second one, because since they are very close to each other, we can use either one of them. So for lat, it takes latitude and it takes longitude. So this will center the beginning of the visualization. And after that, we'll just fill that in later. Also inside of the map box, you have the zoom option. And this, as you might imagine, defines the initial zoom. This is a trial and error approach. It needs to be a number bigger than 1 or 0. You would just try it until a number that really fits your visualization in terms of initial zoom appears. As for this one, I believe 7.8 is very good, but yeah, it is what it is, right? So we just need to find some latitudes and longitudes. One, to begin our visualization, we'll use them from the data set as well. So remember, it had the latitudes and longitudes of every municipality. We only need one, don't forget. So for that, we'll use the iloc method. You could type this manually. So if you had the values themselves, but the iloc method to get the first value in terms of index, so which is 0. And lan. So it's not lan, it's lat. And now you just, yeah, you just need to render it. So Choropleth. Let's just copy it from above as well. There's no need to type this. So since we've copied the name of the variables, we're overwriting them, but yeah, it's the same thing. So data Choropleth, layer Choropleth, here we build the figure Choropleth, it matches, and now we show it. So here it is. So it's fairly zoomed in. The first one is probably Sobral de Montegraço, I don't know. The one in the center is the one that we chose in terms of, okay, here it is, the center lat and longitude. And well, here we have it. And if you zoom in, actually this GeoJSON has a very big degree of detail. So there are a lot of points that define the boundaries. Yeah. The other GeoJSON, it's really big. So in Moodle, so before we go into the density map box, there's also regarding your pure luck question, sometimes it is normally the GeoJSONs do not have the ID field. So I've built this Lisbon, the municipalities of Lisbon, from the Portugal Municípios GeoJSON, which is also a GeoJSON, which means it is a dictionary with feature collection features, an array with features, type feature, etc. But normally they do not bring an ID, at least ID equal to what we want. So what I normally do, or people normally do, is manipulate. So here it is. So the GeoJSON of the Portugal municípios, which has all of the municípios, and it doesn't have only the Lisbon, the municípios from Lisbon, municipalities from Lisbon. Inside of properties, remember where it was the place where it had the information, has ID2, ID0, ID1. It has a lot of information. Here is where you store the information in the GeoJSON for each of the countries' partitions. In this particular place, I've chosen for the ID the name to, which is what's being done here. Actually, this is a filter for Lisbon, and here is where I've added the ID key to each feature. So in order to answer your question, it's not pure luck. Normally, you need to do a bit of manipulation. But since it has a very fixed structure, it also always has geometry and properties where it has information. You can easily find the way to do it. Yeah, but here is how I've done it. So I believe it's a decent example. But moving on. So this was the exercise. We end up with a choropleth of Lisbon's municipalities. Pretty decent. This is purely fabricated data, so don't worry about it. And now we go into the density map box. So the density map box, it's a merge, it's a mix between the scatter and the choropleth, in terms that you have latitude and longitude, but you have a value associated with it. So this is a bit of data preprocessing of the emissions dataset. So we've chosen only the year of 2000. And then I don't know if you remember, we had the country points dataset that we used for the first example, which only had the name of the country and their longitude and latitude. And here we merged them, the emissions dataset, with that dataset. So we ended up with the emissions dataset where we have the latitude and longitude of each country, as you can see here. And we've only chosen the columns that you're going to use. So that's the data preprocessing that we've done. So we end up with country name, a value, latitude and longitude. If you remember, for the Geo Choropleth, we only needed the country name and the CO2 emissions. For the scatter Geo, we only needed the latitude and the longitude. For this one, it's a map box, which means we need to give it a map in forms of layers, but it receives latitudes, longitudes, and the value, which means it doesn't merge with the GeoJSON at any point. So when you do this, you need to be sure that the projections in the GeoJSON and in your dataset are the same. If not, things will not match, because this is not merging the data with the map itself like it does in the Choropleth. What we have here is points, X and Y, or latitude and longitude. Each point has a value associated with it. In this case, the CO2 emissions of that country. It has a text, color scale, color bar, even a Hoover template in this case, but as you remember from that class, last class, that's simply what you see when you have your mouse over something. Again, Mapbox, we define the layers, and we have a simple title. So in terms of structure, is fairly similar, and you can. Okay, I need to run deep reprocessing part. And it's kind of hard to explain what a density map is, so it's better to show it. Since this is using the GeoJSON with all of the countries, this will be fairly slow. This one runs at least compared to the Choropleth. So just run it. And let's just wait a bit. So it's almost there. Okay. So let's wait a bit so it can render everything. So, but as you can see, it associates one point to each country, as we had with the normal scatter, and each point has a value. And what it does, you can zoom in and zoom out to see, is attributes a density to that point or size. And the cool part about it is that when you have many points close to each other and you zoom out, it merges the points together. So what you can take from this visualization is that, for example, even though we know that the USA and China have a very big emission rate, this is log scale, but not very, you can see that Europe, having the same size, seems to have, in terms of global, so globally, higher emission rates than China and the USA. So it's not really. Is it just slow or printing out any error?
Is it because it sums the values? So it seems that Europe has higher emission, so it is summing all the countries together.
Yeah. See, visually speaking, it sums the emissions, right? Yes. So the thing is, although we know that China and America have a high emission rate, since they are very big and Europe has a high amount of partitions with a lot of countries, we can assume that maybe all of the partitions countries have a higher emission rate of China and the USA compared in terms of size. So, oh dear. Oh, that's not a mistake. I also have that. That's just a warning. Since there are very small values, the logarithm, there isn't logarithm of 0, right? So since there are very small values, very close to 0, he prints out a warning, but he passes them by. Don't worry about that. If he doesn't print out an error. Oh, showed up. Nice. So as you can see, it's a very different kind of visualization in terms of spatial visualization, but it might have its uses. So that's it for all of the different kinds of visualizations. But as for, I still want to leave you a final exercise to do, which is basically a density map box for the Lisboa municipalities example. And since we only have like 7 minutes of class left, you can either do it now and I try to answer any question that you might have, or, well, you can do it as homework. Also, the rest of the code is how I built the GeoJSON for Lisbon using another GeoJSON with all of the municipalities from Portugal. So if you're interested in knowing how the GeoJSONs are used and how you can manipulate them better, you can take this as an example. So, but yeah, here you have an exercise. So any doubts regarding this particular exercise? So in terms of layout, you can basically copy the previous layout that we've used since we are using the same GeoJSON. The only thing we need to change is the trace itself. So you can just copy the previous layout and copy this trace and just appropriate the latitude, longitude, and Z value and text. And but this particular map is very heavy. So if you zoom in, you can see it has a lot of detail. Yeah. Yeah, but if anyone doesn't have any question left, also we can end the class here. You can either do it now. I'll stay here for a bit longer, but yeah, if you don't want to do it now, or you're just around time, like it's 8:30, you can do it as a homework. But yeah, in terms of class, we are done.
Professor, thanks a lot. I have to go.
Oh yeah, sure. Well, thank you.
Bye.
Bye.
You have a good night.
You too. Oh, good night. Oh yeah, sure. Bye. Night. Oh yeah, and well, most of you are already leaving, but next week I don't know if it's already vacation, but the next classes will be with Professor Pedro Cabral. So yeah.
Thank you, Professor. Good night.
Thank you very much. Have a good night. Bye-bye.
Bye. So since it is almost time and since there hasn't been any doubt, I'll just close the session, okay? So see you all. We won't have classes next week, at least with me. I don't know if it's vacation already, but nonetheless, the next class will be with Professor Pedro Carol. So have a good night. Well, see you. Okay.